Hey everyone, today we're going to talk about domain and range. We're going to start on page 6. Remember, we're doing numbers, even numbers on the left, odd numbers on the right. So we're going to start on the left-hand side and move on to the right today. Once you get that down on your table of contents, I know I'm zoomed in a lot here, but again, we're going to start on the left-hand side. So I'm just going to fold this over. And again, this is page 6. So last time we started the notes right up at the top, but this time I want us to leave room for an entry task. Because when you come in next class, there'll be an entry task and you want you to put the answers in this space. So what we'll want to do is put a title. And there's my title for my entry task, and I always like to give it a date. Again, you might need to adjust this if you are in my odd periods, but we're going to do this on Friday the 18th, so you'll date it for whenever our next class is, and then 2020. Okay, and then what I'm going to do is go down a little bit. It's not going to be a crazy big entry task, and we're going to put a line, and then we'll be ready to title and date our notes. So over here under our entry task, I now have our title, which is domain and range. That's just an ampersand. You can write the word and or like a plus sign, I don't care. And remember, we date it for the next time we're going to have class, which for this class right now is going to be the 18th. LT, recall, stands for learning target, and the whole goal today from the notes is that you can define domain and range and identify them from discrete and continuous data. So that is a callback from last week. So here we have the actual definitions of domain and range, because that's one of the things we want to be able to do. And domain is the description or set of all x values in a scenario. Okay, and that again would be tied to independent variables, right? Because those are related to the x's. And the range is the set of all y values, which is related to dependent variables because those are related to y values. Now notice I put like a little speech bubble over here, and that's just because I wanted to make like a little side note. We use curly brackets for sets. If you don't know what a curly bracket is, you're going to find out in a little bit here, but that is a way to kind of package up a set and say, this is what I'm talking about, these numbers. And now you'll see I have in my hand some highlighters. Because we're going to be talking about domain and range, and we're going to talk about them over and over and over again, I'm using some colors to color coordinate. So if you want to color coordinate with me, domain, I'm going to use pink. You don't have to use pink, but you want to pick a color. And a different color, I'm going to use green for range. So now as I go through and you see these colors, pink will be connected to the domain and green will be connected to the range. So how do we write these sets? Because we're told that they're sets. So there's a lot of different ways to do it. We're only going to learn 2 right now. The first one's called roster notation. And think of almost like the roster for a class. It's just literally a list of all the values, just like a roster would be the name of everyone in class. But we need to put them in ascending order, meaning it starts with the lowest numbers and goes to the highest as you go from left to right. And don't list any repeats. So if a number occurs more than once, you just need to put it one time. And then notice I added a little note here. We want to use this for discrete data, okay? Because remember, we learned that there's multiple types of data, and again, that is part of our learning target. So I wrote some examples here. So here is my first example. Notice smallest number is -3, 7, 28, 100. They get bigger from left to right. And what are these? These are the curly brackets I was talking about, and that was a pretty bad arrow. Curly brackets. Okay, so you want to add that in, so sometimes I'll write them with you. This is called marking your notes, okay? It's when you point out something and essentially you need to make a note so that you can go back and reference it. So those are the curly brackets I was talking about. They're not always this pretty when I do them, but there they are. And then notice I did another example that looks a little different. It has these dot, dot, dots at the beginning and end. Those are called ellipses, okay? And in math, it means to continue in the same pattern in that direction. So sometimes you might only have it to the left, and that means that it continues that way in the same pattern. Well, the pattern as we go this way is just going down by 1. 0, -1, -2, -3 would be here, -4, -5, but it means that it doesn't stop. So remember, this is a list of values. I can't list all the values, right, in this particular instance. So I had to do a dot, dot, dot. And then this dot, dot, dot means it goes forever that way too. Again, sometimes you might just have dots to the right. So again, it means that it has to follow the exact pattern that you see. If it was going by 2s, then the dot, dot, dot would imply you have to continue going by 2s. So what these mean is that we continue forever. That pattern continues forever. Okay, and again, you might only have this on one side, you might have it on both sides, but I do want you to see it. We won't use it much. Ours will mostly look like this first one. The other way we're going to describe sets or show them is to use inequality notation. So the way we do this is we use the highest and lowest values as bounds to kind of say, hey, this is the lowest it'll go and this is the highest it'll go. And if it goes forever, kind of like our dot, dot, dots, instead of using dot, dot, dots, we use either positive infinity or negative infinity. Okay, and notice I made a little note. We use this style for continuous types of data. So again, I have some examples. So again, notice I've got these curly brackets, and then all of a sudden you're like, hey, where in the world did this n come from? Well, I'm just using it as a placeholder. In reality, what we would want to use is x or y. We would use x for domain, and use y for range. Okay? I didn't want to put an x or a y in there right now because I didn't want you to think it would always be that way. But that's what will happen. If you're describing the set of all x's, put an x there. If you're describing the set of all y's, put a y there. And same goes for over here. Now notice I also included this negative infinity. Well, that means that it must go forever to the left because negative infinity is that way on a number line. So this goes forever to the left. Now, there's one more thing we need to pay attention to in these examples, and this part will come back, so you don't need to worry a ton about it. But if you look at these inequalities, they all should open to the biggest number, right? So of these, the biggest number is 0, and they all open towards it, like nom nom nom. Same thing over here. The biggest number is 18. These are all nom nom open to that, okay? But there's a line under some of them and not under others. Line under this one, but not under this one. And that line stands for or equals to, right? So -7 is less than or equal to n. Here, you would just say n is less than 0. Now, here's the easy part, though. It's actually not as bad as it looks. You'll always use this unless two scenarios. And the two scenarios are when there's an open circle on a graph, or it goes forever, or you use positive or negative infinity. So, essentially, we drop the equal to part only for open circles on graphs and plus or minus infinity. Okay, and by putting that together, it just squashes the plus infinity and the minus infinity together. So those are the only two ways. Otherwise, just always do a little equal sign under it. So we'll do a scenario on the next page that includes both of these, so you'll see what I mean. But I think it'll be a little bit easier than it sounds right now. Okay, and then the last thing here before we actually start doing examples of domain and range is, notice you have to determine discrete or continuous so we know which notation to use. So my suggestion is to first always look at the context of the problem. If there's labels in the table, if there's a little story that goes with it, if there's labels on the graph. A graph will be easy to tell though because it'll either have dots or lines, but a table is much more difficult because a table just lists numbers, but depending on what the table represents, it'll put it into either discrete or continuous. Okay, so let's actually start to look at how we write domain and range and determine it for different scenarios. So we're going to go on to page 7, so the other side here. And the first thing I'm actually going to do is just go ahead, split the whole page down the middle again because we're going to have a continuous side and a discrete side. All right, so here is my paper divided in two. I have discrete on this side, and I put a little note to myself that that's going to be roster notation, and continuous on this side, and a little note to myself that that's going to be inequality notation. And I realized that I made a little bit of a mistake, but good thing I have whiteout, or if you're using a pencil, but I'm going to have to white out a little bit to get what I want in here. But we need to look at different representations. So the first one we're going to do is for points. Okay, so the first way that you can receive data would just be like a set of ordered pair or points. Okay, so you can see this is where I messed up. I didn't leave a column to write points, so I just put it in the middle. It's fine, we made it work. So I just listed a set of ordered pairs, just a grouping. There's 6 of them, and I literally did the exact same ones for each of these, okay? So again, this would be based on a scenario, and you would have decided that this data is discrete, but then for some reason this one's continuous. So don't be mixed up on the fact, well, they're just points. Again, we're pretending this goes with some scenario that someone's told us about, or like a word problem. And notice I have D and R for both sets here, and I've color-coordinated them already, and they stand for domain and range. So the first thing we do to write them is D:, and that's like code for the domain is, and R:, and that's code for the range is. And now we need to do the set. So you remember that a set is a curly bracket. So I do know that it's going to start with a curly bracket. And then what I want to do is say, okay, well, domain is the set of all x values. So the x value will always be first in an ordered pair. So this is why I wanted to color coordinate. So I'm going to take my pink and I'm going to find all x values. So I have 4, -2, 6, 0, -3, 0. Okay, so those are my numbers. Now remember, we want to list them in ascending order, meaning we start lowest and go highest, and don't list repeats. So after looking around, it looks like my lowest is -3. And if you want to do like a little check mark on it, you can. Then I have -2. And then notice I have 0 twice. I'm only going to write it once. And then 6, and oops, Miss Azor. Wrong. 4 and then 6. Boop. And then close it. Okay, so no repeats. I'm going to even make myself a little note here. No repeats. Okay. Then we can move on to range, and range is y values. So I'm going to take my color for range, and I'm going to find all those. So 7, 9, -1, 5, -3, -8. Okay, so now I'm going to list those in ascending order, so starting with the lowest. So you kind of look how weird my curly bracket is. It's fine, don't stress about them, okay? And then work our way up. So -8 is the lowest, and then -3, then -1, then 5, 7, 9. Now, this one has 6 values because there were no repeats, and this one only has 5. Guess what? That's okay. You just you just list them, and it's just a description. You don't need to tell them that zero's in there twice. It's just like, hey, what are the numbers? Okay? Now, remember, inequality notation is like a bound. You're saying that it is bound between the highest and lowest numbers. So instead of just identifying all of the x values for domain, we can start with our curly bracket. Okay, and we just want to find the lowest and the highest x values. So I kind of wrote them, I fit more on this side, and that's okay. I'm going to find the lowest. So if I go through 4, -2, 6, 0, -3, 0, -3 is the smallest. Okay, and then I want to find the biggest one, and it looks like 6 is the biggest one. Another way is kind of, we've already found it over here, so we actually already know. But you find those. Now we want to create an inequality from it. So you always put the lower one to the left. Okay. Then we do our symbol. Remember, it includes an equals because the only times you don't is when there's an open circle in a graph. Well, there's no graph here. Or you use positive or negative infinity, and there aren't any of those here. So because this is domain, we want to use an x value, because domain is the x values, right? And then we do the symbol again and the 6 and close it up. So what this tells us is whatever these numbers represented, all the x values are going to be between -3 and 6. Okay, whereas here it's only these specific numbers. This one gives you like a range, this one gives you set specific values. And we do the same thing for range. We want to find the very lowest number, which is -8, and the highest number, which is 9. We again start with a curly bracket, and we do the lowest on the left, and then we do our symbol, and this time we sometimes just get in the habit of writing the same thing, but it's a Y because it's the range. We do our symbol again, and then the highest number is a 9. Okay, so again, I'm just going to make myself a little note here that these two are the lowest, and these two are the highest. Okay, I'm not going to make a note about x and y because if you go back a page, it's written for you right here. For x, use x for domain, always. Use y for range, always. And that is exactly what we did here. We used x and we used y. Okay? So again, discrete, we have to use roster notation because it's just a list of values. Here, remember, the lines are connected, so it includes all the numbers between the lowest and the highest values. Okay? So we're going to move on to tables. So I'm going to pause and draw a line, and we'll get the tables up here. Okay, so now we are on tables, and again, you can see I whited it out. We'll only have one more section after this, so don't worry. There are two tables, but they are not the exact same tables this time. So remember when I said it's about the scenario or the context that determines if it's going to be discrete, which was on the side, or continuous. So notice here I have number of people and number of pizzas. So if I had a party or whatever, a group of people, these are the numbers of people, and that would determine how many pizzas I order. So again, you can't order parts of people, or sorry, you can't order parts of pizzas, and you can't have parts of people. These are countable things. These are all discrete. Over here, I have water depth, which is something that is measured, right, using some tool. And then we have the temperature of the water at that depth, and that is also measured. So that's continuous. So now we're going to have to look at them separately, and that's totally fine. So again, I've already color coordinated. I'm ready to go. Here, remember, we are just listing the x values. Now, the good news is the x values, or the independent variable, is always the first one. So either on the left, if it goes like this, or the top if it goes like this. And this is the good news. It's already in order for us. 0, 4, 8, 12, 16, 20. Boom. We're ready to go. We can literally just take those and write them here. Now, if this was a scenario where they were like, no matter how many people, and it could be above 20, we could put ... meaning it continues in the same fashion. But we're going to stick with the table because obviously I don't have a word problem to go with it. And then we do the same for number of pizzas. Again, super easy to locate because it's just the second column, or in this case, the bottom row, or whatever, bottom row. And again, in ascending order already, 0, 1, 2, 3, 4, 5. So that means I can just do a curly bracket, 0, 1, 2, 3, 4, 5. No repeats or anything. Beautiful. Good to go. Then we have the continuous side. So the continuous side, remember, we're bounding. We're looking for the lowest it goes and the highest it goes. So for water depth, the shallowest or lowest water depth is 50, and the highest is 200. Okay, and again, we were lucky because they was already in ascending order. So we do curly bracket, we do our lowest number first, lowest to the left, and then our symbols, and X because it's domain, and then our symbol again, and then our highest number. And remember, these are all open. If you think of it like an alligator, they're always open towards the bigger number. Again, we're using the equals to because our scenarios are if we use plus or minus infinity, which we didn't, and if there's an open circle on a graph, but we don't have a graph yet, so don't worry, it's coming. Then we again look for lowest and highest for our range or Y values, which is the second row. Now, they are at the ends again, 4 and 18. They're just backwards. So don't just put 18 first and 4 last, okay? We want to make sure that we always do the lowest number to the left, and then our less than or equal to symbol, and then Y, because now we're on range, and then less than or equal to again, and then 18. And there you have it. Now, I again want to make a note because we lucked out. These were already in the same order, but sometimes they're not. So you need to make sure you hunt for highest and lowest numbers, which I'm using the number symbol for. Okay, and that's because sometimes something might rise up in the middle and then fall back down. So the highest number is hidden in the middle. So don't just always go to the ends, even though a lot of time our data is organized like that, which is nice. All right, so I'm going to put a line here, and then we're going to draw some graphs. Okay, here is our last section. It's on graphs. You might want to pause it and write it. I wrote in the points just because I know that can be difficult to see on here, but normally I would not write them in. So you might be like, well, why do you need to do that, Ms. Or if you already have the points written in? The points are to help you draw, okay? If you want to pause, you can pause real quick and draw it. But you cannot really flip these back and forth because, again, discrete has just isolated points. So let's look at that one first. So notice I drew my graph, I put in the X and the Y's. And the reason for that is because domain is X's, which means we look at the side-to-side-ness of it all, or look at how it's associated to the X-axis. Okay? So one thing I like to do is I draw a line from each point to the X-axis. So here it's actually like on an axis, so I'm going to go right next to it. There and there. Okay? And you can see I brought all of those just straight to the axis. And I think I am lucky enough to have a pink pen. And I'm going to write what those numbers are on the X-axis. So if you go back, 1, 2, 3, 4, 5, that's -5. This one's -3. This is not side to side at all, so it's 0. That's 2, and this is 4. So again, I know that you're like, those are in the points. You won't always have the points. So because domain is x values, I drew lines to the x-axis and found out what those lines are. And now, look at that. Here are my values in order already. So all I need to do now is take exactly these and put them in my curly brackets. So the lowest value is -5, then -3, 0, 2, and 4. Okay, then we can do the same thing for range, but now we focus on the y-axis. Okay, so again, this one is already on the axis, so what I like to do is just kind of like draw little marks on either side so I know that there's something there. But then everything else, draw a line to the y-axis. Okay, and again, I'm going to focus on just that axis and where these hit the axis. So here, this one is down 3. So this one is -3, and this one is -1, +1, 2, and +4. And wouldn't you know it, again, those are exactly the numbers I want to use. And if you start down below, they are increasing or ascending. So I can just take them and put them in a set. So we start with -3, -1, +1, 2, and 4. Now, if you ever get stuck on this and you forget what to do, okay, because sometimes these lines can be confusing. It's nice that I've color coordinated them, but you can always, when in doubt, put the points in a table. And then you can do it like the step above. Okay, so you could just create a little XY table and pull each of the points. It doesn't even matter if they're in order, and then you do what you did up here. Okay? Now, for this one, I did draw this really small on purpose because we're going to do more down below. But this is where I promise things were going to get tricky. Yes, you are allowed to draw a graph like this because I didn't have a negative part of a graph. So I just did a little tiny part down here. But here's my line. And yes, that is an open circle on purpose. What's that, Miss Azor? An open circle? Yeah, just like I had been referencing. Okay, so this time I'm going to do the same method, but I only care about the highest and lowest values. So for x, on the x-axis, the lowest value is all the way to the left, okay, which is this number. And the biggest number is all the way to the right, which is this number. So those end up being -4 and +3. So those are my upper and lower bounds. But remember, I said beware of the open circle. So here, nothing to worry about. So do the -4 as usual and do the usual symbol. And X because it's domain. And now, because the 3, I'm going to leave a space and write the 3, has the open circle, drop the equal sign. That's it. And the reason for that is because =2 means it's included. Here, the circle's filled in. It's included. Here, the circle is hollow, so it's technically not included. So you just put the inequality and not the =2 part. And then you close your bracket. Okay? And you're going to see in a second, the same thing is going to apply when we go and do the range. So the range is, the lowest would be down, which is right here. That's the lowest this green line goes, and the tallest is up here. So, on the y-axis, the lowest number here is 0, because it's right at that intersection, and the highest number is 5. Okay? So when we go to do this, we start with our lowest, 0 with a curly bracket. And remember, that's a normal thing. We're ready to go. Just use our normal symbol, and then a y because it's range. And then now the 5 has the open circle. So we just do the inequality. Don't underline it. Don't give the equals to. And the reason for that, again, is because they had an open circle. So since they had an open circle on the graph, you drop that. Because again, if you actually tried to go to this point where the 5 is, oops, it's empty. There's nothing actually there, so you can't put it equals to. Okay? And then we have one more example that's going to include an infinity, and then that's it. All right, guys, here is our very, very last example. And it's probably the most complicated, and I want to show you, but again, don't stress too much about this. Remember, just get the notes done, listen to what I say, hopefully that helps you, and then get the pictures taken and turn it in. When we do domain, remember again, that is based on the x-axis, which is side to side. So we need to know how far to the left does it go and how far to the right. Well, I did a closed circle here, and so that is pretty easy. That is -5. But my problem here is that this is an arrow, which means it doesn't stop. It just keeps going. So what I'm going to do is put a little arrow like that over here, meaning that it keeps going that way to the right. Well, what is that way to the right but positive infinity? Positive infinity is that concept that it just goes forever and never stops and just keeps getting bigger to the positive way, right? So that means we use these two numbers for our inequality. So we again do a curly bracket and start with our -5, which is a closed circle, so nothing new or interesting there. Use your normal symbol. And then x because it's domain. And now that's the different one. Remember, that's one of the ones where we drop the equal sign, so it's just an inequality, and then put positive infinity. And then close the bracket. And there you go. So it's actually not as bad as it looks, okay? Then we do the same, but for range. Now, here's why I did this one. Because look, if you try to use this as your range and bring it over, that is not the tallest part or the highest part of our graph. The highest part is not at this end point, but it's actually up here. That's my highest point. And that happens to be positive too. Okay? So, just because there's an endpoint doesn't mean it's going to be the thing you use. So be careful. And then here, remember, this isn't even the lowest point. Again, this is going to keep going. So again, I'm going to put a arrow, this time going down. Well, what number is down there? This one was positive because it's going to the right. Down is negative infinity. So that's what we use in our inequality. We start with a curly bracket. The lowest number is negative infinity. And again, because you're using infinity, you drop the equals to. You just use that. A y because it's range. And then up here is just normal, less than or equal to 2. Okay? And one more time, I'm going to give myself a little note. That we drop equals to 4 plus or minus infinity. Okay? And there you have it. Okay? So, again, I know it's long notes, but you gotta remember it's like 2.5 days worth of material. And then what we'll do, bring the notes ready to look at, the picture submitted to class, and then we'll be using these to actually apply and figure these out and do some examples of our own. All right. Have a good night.